everyone. Good morning. So today we'll talk about the biochemistry experiment that we have done last week. So last week we have done an experiment. It's about enzyme kinetics. As you all know, enzyme is a protein that acts as a catalyst to speed up chemical reactions in the body. So in the last experiment, we have been studying about an enzyme called cellular bias. Okay, cellular bias is an enzyme that actually breaks down cellulose to glucose. But in our experiment, we have used artificial substrate, which is p-nitrophenyl glucopyromonoxide, and the cellular bias will break down this artificial substrate to glucose and also p-nitrophenyl. So we have done two activities, right, in the experiment. The first one is to determine the rate of reaction in the presence or absence of enzyme. And the second one is to determine the rate of temperature or the rate of reaction of the enzyme. So in these both experiments, we will determine the rate by studying the amount of p-nitrophenyl produced. Right. So now we'll go into activity 1. In activity 1, we need to determine the rate of reaction in the presence of absence of enzymes. So there are a few materials and apparatus needed in this activity 1, which include the substrate, enzyme, stop solution, which is a phase solution, buffer, micropipettes, conical tubes, cuvettes, marker, beaker to expel the used tips, and also timer and spectrophotometer. So we will now ask Lukman to explain more about this.
So basically the procedure will be involved the apparatus being said by Rose just now. So basically we have 7 cuvettes where 5 will be labelled from E1 to E5, and then the remaining 2 will be labelled with start and end. After that, stop solution will be added into these 7 cuvettes. Later, the conical tubes we have will be added with will be labelled with enzyme reaction, and the other one is control E and C. After that, substrate will be added to both of the conical tubes, and then the buffer will be added to the control conical tube using micropipette, and then after it's been mixed, it will be the solution will be transferred to the cuvette, which is labeled from start. After that, the enzyme will be transferred into the conical tube, which is earlier was labeled with enzyme reaction using micropipette, and then the solution from the enzyme reaction tube will be added into the labeled cuvette, the appropriate cuvette, and lastly, by using the micropipette, the solution will be removed from the control reaction tube and then added into the cuvette labeled N. So that's all.
Since we have finished the activity 1, how about activity 2? Can someone explain about it?
So now I'm going to explain further about the experiment 2, which is to determine the effect of temperature on the reaction. But first, I will inform you what are the factors that will affect the reaction. We have the temperature, we have the pH, we have the enzyme concentration, substrate concentration, and also the presence of instigator or activator. So this is a briefing about the experiment. Right. For your information, actually, not all enzyme can. Actually, not all enzyme will denature at higher temperature. Some of them will actually change shape according to the physical properties. Some of them some of them can tolerate to the high temperature. But some of them can also denature at low temperature. But most enzymes they can best functions at the moderate temperature, like 20 degrees Celsius until 40 degrees Celsius. And I think that's the point that I want to tell you.
But now I'm going to tell you the materials that we are using. We have the beaker with the ice water, and we also have the beaker with the 37 degrees Celsius water. We have the thermometer, which is very important, and then we have the microcentrifuge tubes, and we have the enzyme, the substrate, the stop solution, and also microbubble. So, Sarah, can you please tell us briefly the methods of doing this activity?
Okay, sure. Okay. First, we need 4 cuvettes that is level with 0 degrees Celsius, 22 degrees Celsius, 37 and 90 degrees Celsius. Okay, and then we put the stop solution in each cuvette, and we need 1.5 milliliter microcentrifuge tube with level 0 degrees enzyme, 22 degrees enzyme, 37 degrees enzyme, and also 90 degrees enzyme, and we added enzyme to each microcentrifuge. And then we need another microcentrifuge that is level with 0 degrees substrate, and 22, 37, and also 90, and we added substrate in each microcentrifuge. Okay, next, Nantra will explain.
Alright, now I'll proceed to the next procedure. Okay, and then the microcentrifuge tubes level 0 degrees Celsius of enzyme and substrate is placed in the cup, in the ice cup, and then the second one is level 20 degrees Celsius enzyme and substrate put in your lab bench, and then microcentrifuge level 57 degrees Celsius enzyme and substrate also in a warm water at 37 degrees Celsius, and also the last one is 90 degrees Celsius in the incubator. And then have your stopwatch ready, alright? And then using micropipette, pipette 250 microliter of enzyme from the tube level 0 degrees Celsius enzyme and substrate into the tube of substrate. And then place the tube now containing your enzyme and substrate mixed bag of ice in the ice box. And then also the same for the 22 degrees Celsius, you put that bag on the lab bench. And then for the 37 research substrate and enzyme solution, put that back into the water bowl. And also the last one for the 90 degrees Celsius into the substrate, also put in the incubator. And then after 2 minutes, by using the micropipette, for each temperature reaction transfer, you have to transfer 500 microliter of the reaction to the appropriately labeled cuvettes containing stop solution. And then so you allow all solution in the cuvettes to reach room temperature for approximately 5 minutes. So after all the cycle have been done, so this is the ending of the experiment. So that's all. Okay. So I want to ask you about for the practical one, how to collect the results.
Basically, there are 2 ways to collect the result. First, we do the comparison between the reaction sample with the standard cuvettes that are prepared. In this case, we compare in terms of the color. We use the most similar color of the sample, which is same with the standard. And then the result will be used in a qualitative analysis. Second, after finish this comparison, we proceed to the second step to get a more accurate result, which is using the spectrophotometer. The result obtained from this is used for the quantitative analysis, and the result basically it will support what you find in the qualitative analysis. And this is the method. There are 2 methods.
So the spectrophotometer is used to find the absorbance value of the sample, right?
Yeah.
0 something. I just want to add something. For experimental, we are using the similar way, the similar methods by using the qualitative analysis, and also by using the spectrophotometer with the absorbance at 410 nanometers.
So that's all about the experiment. So anyone wants to add something? No? Okay. So that's the end of our discussion. Thank you, everyone.
Thank you.